Here's an imaginative concept reimagined as if a professor is lecturing a university class, using analogies, a chalkboard, physical objects, and references to historical scientific ideas. The tone is engaging but intellectually grounded, as if guiding students through both the metaphor and the underlying science. Like professor's lecture, magnetism as the mirror of the universe. The professor stands before a chalkboard. On the table, a mirror, a Prince Rupert's drop, a strong magnet, a beaker of water, and an old vinyl record. Class, today we're going to stretch the boundary between physics and philosophy, between matter and meaning. We're going to ask, what if magnetism isn't just a force but a memory? A mirror, even a shapeshifter? Let's begin with this mirror. He holds it up. When you look into it, you see yourself. But what if I told you? The mirror is not simply showing you, it's becoming you. Or rather, it's reflecting an invisible form that already remembers how to be you. Now think of this object. He holds up a Prince Rupert's drop, a teardrop-shaped piece of toughened glass. It looks fragile, but its bulbous head is nearly unbreakable, while its tail, if snapped, shatters the whole thing. This glass is a visual metaphor for tension hidden within form. Now imagine that, instead of glass, this shape was made of pure magnetism, invisible but still holding form. This leads us to the heart of today's concept. Black holes are magnetic mirrors, and magnetism is the shape-shifting backbone of all form. Let's write that down. He turns to the board and writes, magnetism, mirror, plus memory, plus morphing medium. Magnetism as a shapeshifter. You all know magnetism affects matter. It aligns iron filings. It sculpts plasma fields on the sun. But what if it becomes matter's form as well? Let's say magnetism is present in water. If the water evaporates into vapor, what happens to the magnetism? According to classical physics, the magnetic field changes with the distribution of particles. But what if something deeper remains? A magnetic memory in a shape code persists and shifts with the phase of matter. Liquid, gas, solid, the magnetism adapts yet retains the essence. That's why this old record here, he places a vinyl on the table, is so interesting. It's not just music, it's encoded memory in a spiral, like magnetism might encode memory in space. Black holes as magnetic mirrors. Now consider a black hole. Traditionally, we say it has no surface, only an event horizon. But from another angle, it behaves like a perfect absorber, and possibly a perfect mirror. Think about this. If a black hole absorbs everything, matter, light, even sound vibrations, but somehow encodes their properties on its horizon, as in the holographic principle, then it behaves like a magnetic memory field. The reflection we see in a mirror, then, might be just a shallow echo of what black holes do perfectly. They don't just reflect, they remember. Imagine this, you approach a black hole. Your image is pulled into it, not just physically but energetically, and that information is preserved in a form of magnetic memory on the event horizon. It doesn't vanish. It waits, in tension, like the glass drop. Reanimation through magnetic memory. Here's the final leap. What happens when none of these forms, solid, liquid, biological, remain? The magnetism that once animated them still holds the structure, like grooves in this record. So maybe, just maybe, magnetism is invisible but structural, responsive but indestructible, reflective but conscious. A medium that remembers all forms it has inhabited. That would mean black holes, far from being voids, are dense archives of form, built of magnetic reflection. And mirrors in our world are just flat echoes of this deeper cosmic property. Closing thought. So the next time you look in the mirror, think beyond photons bouncing off glass. You're looking at an invisible field, shaped like you, remembering you, using light as its language. And somewhere at the edge of a black hole, that reflection may be written forever, in magnetism.